What if the toxins in your food and water weren't just harming our bodies, but rewriting the very code of human health? My guest today, MIT scientist Dr. Stephanie Seneff, has spent over a decade connecting the dots between environmental toxins, metabolic chaos, and neurological decline. You'll want to hear every word of this conversation. Did you know sweating can literally heal your cells? Infrared saunas don't just relax you, they detox your body, balance hormones, and boost mitochondrial energy. I'm obsessed with my health tech sauna. And right now, you can save $500 with my code at healthtechhealth.com/dr muth req 25. Welcome back to Let's Talk Wellness Now, the show where we uncover the root causes of chronic illness, explore cutting edge regenerative medicine, and empower you with the tools to heal. I'm Dr. Deb, your medical detective. And today we're diving into how environmental toxins and nutritional imbalances are silently shaping chronic disease patterns, from autoimmune disorders to neurodegenerative decline, and how we can take back control of our health. So, as usual, grab your cup of coffee, tea, or whatever helps you unwind, settle in, and let's get started on your journey to deeper healing. So, Dr. Seneff, so glad to have you here. I can't wait to have this conversation with you. We were just chatting off camera a few seconds ago about what we're going to chat about, but tell us a little bit about your background and how you got into this field of looking at toxins and mitochondria.
Okay, yeah, my background is a bit eclectic. So it starts out with biology. I have an undergraduate degree in biology from MIT. My PhD is in electrical engineering and computer science. So that's quite a switch over. And most of my career, I was writing computer code to train computers to talk to humans in a natural conversational interaction with computers. We were pioneers in that space. You can see that it has really taken off now.
Absolutely.
And actually by 2006, 2007, I started to realize that the kind of work I did already then was getting compromised by the emergence of AI. And I got concerned that I wouldn't be able to sustain the path I was on. And it's happening now, of course, to the young people today are facing a crisis in computer science, because it used to be if you had skills in hacking code, you were good to go, and that's just not true anymore. So that's another whole story. But anyway, I decided I needed to do something different, and I pivoted in a big way in 2007, managed to get the company that had been funding me, a Taiwanese company called Quanta Computers, and they were willing to switch over to funding me to do research on health and toxic chemical exposures, which was a miracle that they let me switch over to that, and that was fantastic. In 2007. So it's been almost 20 years that I've been looking for toxic chemical exposures and their association with human disease, and I focused initially on autism and heart disease, kind of for personal reasons, because I knew people who had those issues. But it led into a much bigger story, and I'm super excited about what's happened over the last 20 years. It's been a continual learning experience for me, and I've just kept broadening my space in biology, furiously reading papers as I discovered new concepts and trying to explore those and opening up new windows. And it's just been a profusion of learning over the past 20 years. And I've published many papers at this point, peer-reviewed papers on the topics of toxic chemical exposures and disease, particularly glyphosate is the one I really focused on. And I wrote the book, Toxic Legacy, How the Weed Killer Glyphosate is Destroying Our Health and the Environment. That was published in 2021. So I'm
sure you have a few thoughts about the administration wanting to bring that back to be made at home instead of China, right?
I know, that's so interesting. And actually, he makes a point that I agree with, which is that we are relying on China for importing a whole bunch of stuff that's really toxic, and we're pouring it all over our food supply. So China is probably very happy to poison us,
Oh, absolutely.
It's kind of ironic that we're doing that. And he makes a good point that we shouldn't be relying on China for these chemicals that are poisoning us. But where he misses the point is he says, well, we just need to poison ourselves, rather than getting rid of that chemical. We need to really change the way we grow food. I think it's number one most important thing right now in America is to change the way we grow food. And it has to be certified organic, regenerative. We need to focus on healing the soil, just as we have to heal the gut. I mean, we've really messed up the microbiome microbes in both the soil and the gut. And the consequences, as you can see, are a huge problem with human disease.
They're devastating. I mean, we have so much chronic illness and so much neurological disease these days. And just the rise of autism, it should be telling us that we're doing something wrong, right?
Absolutely.
We have a problem. For those people who are listening that don't understand what the term glyphosate is, can you explain that a little bit to them?
Yeah, so it's one of the many herbicides that we use. We use herbicides, fungicides, and insecticides in agriculture, all these poisons. And it kind of seems crazy to me that we would think it's okay to pour poisons all over our food supply. I don't understand why we think that's fine.
Yeah.
Categorically. Glyphosate is supposed to be a wonderful chemical because it's an herbicide that kills all plants except for those that have been engineered to resist it, and supposedly is completely harmless to humans. And that's what gets to be, disbelief, because how can something so toxic to plants be harmless to humans? Just how can it be?
We haven't been re-engineered like the seeds that they use from Monsanto. So how can it not affect us if it only affects everything but their seeds that they've modified to make grow beautifully under that condition? It doesn't make any sense.
Right. And of course, the critical thing they missed is that our gut microbes do have that pathway. It's the shikimate pathway that it disrupts, really critical in all the plants and in most of the microbes in the soil and in the gut. And so it kills off the microbes as well as the plants. And when it kills off your gut microbes, you got to watch out because gut dysbiosis is a huge thing. And we've had so many papers coming out lately talking about the relationship between gut dysbiosis and all kinds of different diseases. And not
Do you
just
think that's why we see so much gut dysbiosis these days?
Absolutely. I think it's not just glyphosate because we have lots of poisons that are messing up our gut microbes. But glyphosate is a really big one because the shikimate pathway is essential for many of the microbes, and they use it to make essential nutrients for the host. So we get compromised as well, just because they can't make those nutrients. Inadequate supplies.
So much harder today to treat people with gut issues than it was 25 years ago when I started. It was so much easier. And now it's like nearly impossible sometimes to get some of these people back to a good, healthy gut microbiome, no matter what you do, no matter how well they eat and all the things that they do. It's a struggle for sure compared to what it was 20 years ago.
It's interesting that you have that personal experience because I think people like you really can see what's happening and can appreciate the difference between then and now. I, of course, as a child, autism was not something I knew about at all. There was no such thing really when I was a child. It didn't exist, basically. I mean, it was so rare. And now, everyone knows someone with autism, pretty much.
Yeah. Autism and Parkinson's and Alzheimer's seems to be just so much commonplace. Everybody knows somebody in their family that is affected by one of those disorders, if not multiples. And we tend to say it's genetic, right? Well, there's got to be a genetic. Why wasn't it genetic 50 years ago or 100 years ago? But now all of a sudden it's so prevalent in our environment that we've just become acceptant of it. And I think that's wrong for us to do that. We shouldn't be doing that.
I know. I find it very interesting how quickly it appears that humans adapt to the new normal. It's normal that you have, 3% of the kids have autism. That's normal. It's just like, no, it's not. And also, of course, all the Alzheimer's and dementia and Parkinson's, as you mentioned, in the elderly, those are connected because they're all related to brain problems that are being caused by chemicals that are destroying the brain.
So how does glyphosate interact with our body's ability to absorb those essential nutrients like sulfur?
Yeah, well, that's a big question. I don't know where to begin with that one. Glyphosate, it's a train wreck for the gut microbes, and then that causes the gut dysbiosis. The microbes are unable to produce adequate amounts of nutrients that are essential for the host, and as a consequence, the host cells get sick. So the colonocytes get sick because they're not getting adequate nutrition because the microbes can't produce the nutrition they normally would produce. I think that's a good summary of what's going on. You get inflammation in the gut, and then the inflammation causes immune reactions. So you get the immune cells coming in and they create inflammation. It's just like there's a kind of a festering going on in there that's really a train wreck for the whole system.
Do we see different results with things like this in Europe where they're not allowed to use a lot of these chemicals that we're allowed to use here?
Yeah, they are allowed, but it's much, much less there. My friend, Tony Mitra, got his government, Canada, to do a big test of over 8,000 samples, food samples to look for glyphosate. The U.S. government doesn't bother to test for glyphosate because they consider it to be safe. But we know it's all over our food supply from work by people like Zen Honeycutt. My friend friend Zen Honeycutt of Moms Across America has really been on a mission to test all kinds of different food samples for glyphosate and finding it extensive in our food supply, in the school lunches, in the fast food restaurants, and the food that's fed to the army. She's done all these different studies. Breast milk, wines, all the wines were contaminated. Even the biodynamic, which are organic, had small amounts of glyphosate. So it's just like it's all over the food supply. Canada did 8,000 samples. Tony Mitra finally got them to do that after many years of harassing them, and then he published the results in a book called Poison Foods of North America, because they found that they had imports from Europe, imports from Mexico, imports from the US. And basically the US and Canada came out way on top. As far as overall, the numbers were much higher in those two countries. And Mexico lined up with Europe, which was quite interesting to me. So, you're better off if you buy food from Mexico.
Yeah. And I wouldn't have thought that. I would have thought that was different.
I know you often think the Mexican food is not going to be as carefully regulated, might get some kind of toxin. You don't expect Mexican food to be healthier than American, but it is.
Yeah. Yeah. Can you talk a little bit about deuterium? What is deuterium?
Okay, that's a good place to start. Yeah, deuterium, I'm absolutely fascinated with deuterium. And I believe that the team of researchers that I'm working with, we are onto something really huge. I'm super, super excited. I almost can't contain my excitement with this, because once we started looking, it's just like everything made so much sense. Everything kind of came together in terms of metabolism and disrupted metabolism and all the stuff that's going on in the gut. It really, really makes sense. Deuterium is heavy hydrogen. It's a natural element. Hydrogen is the smallest element, the upper left corner of the periodic table, 1 proton and 1 electron. And it's by far the most common atom in the universe, and in our body as well, by far the most common atom in our body. And it's involved in all the chemical reactions that take place. And so, have carbohydrates. The hydrates is hydrogen, in the word carbon, hydrogen, carbohydrates. And of course, carbohydrates are basic foods. So anyway, deuterium has an extra neutron. It's just like carbon-14. So carbon-12, carbon-14 is a little bit heavier. It's got 14 instead of 12. It has extra neutrons. So there are these kind of isotopes of various atoms. But hydrogen has hydrogen, deuterium, and tritium. Tritium has 2 extra neutrons. It's very rare. And deuterium has 1 extra neutron. And it's rare compared to hydrogen, but it's not rare because hydrogen is so common. So it's actually present in the blood at 5 times the level of calcium, for example. So it's not rare, but it's a very interesting atom that has caused us trouble in the mitochondria.
Is it actually considered a toxin?
It's a natural element. You have natural elements that are toxic, like some of those metals, like mercury, for example, is a natural element, but it's toxic. So it's not a chemical. It's not a chemical, not made in the chemical lab. It's just an atom, and it's all over the universe. It's not like you can avoid it, or you can, you can't get rid of it. It's everywhere. And so it's a natural part of biology, and our biology has evolved to very, very clever ways to protect the mitochondria from deuterium. So the thing is, mitochondria have ATPase, which makes ATP, and ATP is the universal, it's the energy source for the cell, ATP. It's made in the mitochondria, very, very important, oxidative phosphorylation. That's sort of basic in biology. And those ATPase pumps depend upon hydrogen flowing through the pumps to generate motive force to make the ATP. And they pile up the hydrogen inside an inner membrane space. They're kind of cute. The mitochondria have this internal matrix in a hole, like a donut hole. The matrix is where a lot of activity is going on. And then there's a membrane, but the membrane has both an outer membrane and an inner membrane. So there's an intermembrane space where the mitochondria dump a lot of protons. They put lots and lots of protons in there. And then the protons naturally come out through basic physics. They come out, and the pumps are there to grab the energy as the protons come out. It's quite cool. Go back into the matrix. The protons go back into the matrix. So what the body does is it tries to keep deuterons out of that intermembrane space. It tries really hard not to put deuterons in there. So deuterons are the equivalent of protons. Protium is the normal hydrogen, and then deuterium is the one with the extra neutron that makes it twice as heavy. So because it's twice as heavy, it behaves very, very differently. It's kind of like a big bulky thing coming through the pumps, and it can clobber them. It can really mess them up. And the body knows that. And so the body has designed incredibly elegant mechanisms to keep the deuterium levels inside that intermembrane space as low as possible. The body obsesses on that. And once you realize that, all of a sudden, lots and lots of things make sense in terms of looking at biochemistry and what's going on. All kinds of things that didn't make sense before suddenly come clear, are motivated by this idea of avoiding deuterium in the intermembrane space. So it's really, really fascinating biology.
So does the glyphosate tend to increase the deuterium in that space, or does it disrupt it?
It definitely increases it. And the reason why is because it disrupts the enzymes that manage it. And so, for example, I have to get into hydrogen gas and microbial production of hydrogen gas, which is central to the story. And, people get gassy, they have like bloating and stuff. There's a lot of that going on. That's because those gases that are being made by the microbes are unable to be brought back into organic matter. So normally the microbes make lots and lots of gas, and they start with hydrogen gas, and they make methane gas, they make hydrogen sulfide gas, they make all these gases. And then they use those gases as reducing agents to come back and make organic matter. So they basically convert food into basic gases like hydrogen and carbon dioxide, right? Mm-hmm. And then they take the carbon dioxide and hydrogen to convert it back into food. And the reason why they do that is because the process of making the gas tremendously strips out the deuterium. This is absolutely central, I think, to metabolism. And it's not something very many people are aware of. The microbes make the hydrogen gas, and when they do that, they lose 80% of the deuterium, because the deuterium tends to stay in the aqueous space because it's too heavy. You just think of, trying to lift out. If you're twice as heavy, it's a lot harder to get out of the liquid into the air. So basically to make the gas, when you make the gas, you lose a lot of the deuterium. And that is super, super central, I think, to metabolism.
So if that's what's happening inside of there, it's obviously creating metabolism issues. What does that mean for energy and mitochondrial health then?
Well, what happens is that the microbes are unable to make enough of those nutrients that are super for the host that have low deuterium. And a particular one that I have in mind is butyrate. And I don't know if you know anything about butyrate.
Yeah.
But it's a very healthy resource for the gut. The colonocytes lining the gut, 80% of their food is butyrate. They love butyrate. Normally. Mm-hmm. Well, lots of people have butyrate deficiency in their gut. And that deficiency is due to the fact that the microbes can't make the hydrogen gas, because when they make the hydrogen, or they can't bring the hydrogen gas back in to make the butyrate, because the butyrate comes from the hydrogen gas that's produced by the gut microbes.
So if we supplement with N-butyrate, does that help that process work better, or does it not really do much with the deuterium then?
Well, it's a big question with supplements, and I'm really starting to appreciate this more. I always like natural, right? Natural versus synthetic. And I think there's a huge difference for many of these supplements that are popular. There's a huge difference between natural and synthetic.
Yeah.
And that big difference has to do with the level of deuterium, because if it's made synthetically, it's not going to be depleted in deuterium. So when you're taking, and I don't know butyrate, you have to go and look at how they manufacture it to see if it comes from natural or synthetic ingredients. It's extremely interesting with, I've looked into some of these other nutrients that people like to take as supplements. Choline bitartrate is one that I really was fascinated with, and there are papers that show that if you take choline bitartrate as a supplement, so choline, of course, is a very important nutrient. A lot of people are deficient, especially if they're vegetarian. And choline bitartrate is a synthetic form of choline. And choline bitartrate, if you take, the studies have shown, there's a beautiful study that had people who ate a bunch of eggs, because eggs are high in choline. And then they had people who took choline bitartrate to get an equivalent amount of choline in their diet compared to the eggs, right? And the people who ate the eggs were fine, and the people who ate the choline bitartrate were not. They had a very big increase in a metabolite called trimethylamine oxide, TMAO, in the blood. And TMAO is a risk factor for a huge number of diseases. All the usual suspects: the diabetes, the cholesterol, the heart disease, cancer, all kinds of diseases. TMAO is a very interesting molecule that's been studied quite a bit recently. There's a lot of papers on it. I don't know if you've heard of it, TMAO.
I have, yeah.
Yeah, okay. Well, that one is it's very, very interesting. And I have a paper that I'm trying to get published right now that I'm quite proud of that talks about all of this. But they found that when you eat the eggs, you get the choline that way, you're fine. But if you take the choline bitartrate, you're not. You get all this TMAO. And the reason I think is because the microbes make TMA from choline, the trimethylamine. Choline has a nitrogen atom with 3 methyls attached to it. And those methyls are going to be really low in deuterium because they're part of the methylation pathway, which microbes make sure those methyls are low in deuterium. So the whole methylation pathways, I think, is a distribution system to deliver low deuterium nutrients throughout the body, not just in the gut. And the body has all these ways of hooking putting methyls onto things and then taking them off. And when it takes them off, it metabolizes them in the mitochondria, delivering to them low deuterium nutrients. So when you take the choline by tartrate and it's not low deuterium, what happens is you end up with molecules of TMA, trimethylamine, that have deuterium in them. And when you have those, the microbes won't metabolize them. They won't turn them back into hydrogen, deuterium depleted hydrogen. They won't do it. So they stick around. The TMA doesn't get metabolized, and then it gets sent to the liver. The liver turns it into TMAO, and now you've got your problem. And I think TMAO is a marker for deuterium overload in the mitochondria, in the methylation pathways.
That's interesting that you're talking about that. I belong to a group when we've been researching plasmalogen therapy, and one of the supplements that was created with a large amount of phosphocholine. And by itself, when we used the phosphocholine in one of our formulations, it wasn't bad. But when they doubled the dose and they were putting it in all of their formulations, people were starting to see the TMO levels go up. And we were trying to figure out like what's happening here. It wasn't everybody, but it was a good chunk of people, enough for us to say, hey, something needs to change here. We need to take out this phosphocholine or not use as much of it. But now this explains exactly why the TAMO was going up. And if those people do have a lot of deuterium, maybe why we saw some people have a problem with it, but not everybody had a problem with it.
It depends on their microbes. If their microbes are healthy enough to be able to metabolize the TMA, they're fine. And the microbes produce the TMA and then they metabolize it. And they're doing that to generate more deuterium depleted nutrients. They're constantly trying to come up with new nutrients that are deuterium depleted to feed to the host. I mean, they're really obsessed with it. And they do a good job normally, but they get so messed up by all these chemicals, and not just glyphosate, of course, all the chemicals in our food and in the air. It's a mess, It's
amazing the body works as well as it does every day, right?
I really am surprised that we don't have more people who are super sick,
Exactly.
We have enough for sure, but some of us are doing okay with it,
Yeah, exactly. So when we have this high level of deuterium, high levels of glyphosate, what is that going to do to the body's energy stores?
Well, it's going to wreck the mitochondria, and then you're going to get chronic fatigue. And I mean, I think chronic fatigue syndrome, to me, is a very clear example of mitochondrial damage due to excess deuterium. I think that can completely explain that disease.
Do you think this high level of deuterium is causing people to see more neurological diseases as well, like Alzheimer's and Parkinson's? It's fueling it.
Absolutely, because the brain has so much dependence on energy. The brain uses a lot of energy, and they need really healthy mitochondria. Neurons have lots of mitochondria. Neurons and muscle cells really, are loaded up with mitochondria, and both of them get injured when they don't have when they can't keep deuterium out of the mitochondria. The cells get injured by all the reactive oxygen the mitochondria are producing, which the ATPase pumps, once they're getting contaminated with all that deuterium, they start spewing out reactive oxygen. It kills the mitochondria, then it kills the cell, and then it kills the brain. It's like a progression. It really starts with the mitochondrial damage, and then the cell dies. And once the neurons start dying, then the brain dies, and you've got all these symptoms.
So can we measure deuterium like we can glyphosate in the body?
You can, yes. In fact, you can do a saliva test and send it off and get a level of how much deuterium is in your saliva. I would love to know in more detail how much deuterium is in different parts of the body, because that's really quite interesting to me from my studies. What I'm suspecting is that the body, so the cells actually dump deuterium outside the cell. That they're trying to get as little deuterium as possible inside the cell, and within the cell, they're trying to get as little deuterium as possible inside the mitochondria. So there's layers of trying to get rid of the deuterium. And so the convenient thing is to dump the deuterium outside the cell. So there's a lot of deuterium in bones, for example, probably in your skin, any kind of exterior material. And the sort of glycocalyx. So there's this glycocalyx that lines all the blood vessels. And that's these sort of complicated sulfated complex sugar molecules that create gelled water. This gets into Gerald Pollack's work. I don't know if you know anything about Gerald Pollack and gelled water, but that's quite a fascinating field all by itself. But it has to do with really fascinating stuff, because Gerald Pollack talks about a battery being created by the gel. Now, he's done a lot of research on gelled water, like Jello, for example. You put some powder, you put some hot boiling water, you let it sit, it gels up. It's mostly water, but it's a funny phase of water. He calls it the fourth phase of water. He wrote a whole book about that. Gerald Pollack did. And it's a gel phase. So water has, the liquid, the solid, the gas, and then the gel. And most of the water in our body is gel. is gelled, and especially all the water lining the blood vessels. The blood vessels have free-flowing blood in the middle, right? But along the edges, they have this gelled water that's created by these sulfated glycosamiliglycans. They're called, complicated word there, but they create the gelled water. And the gel, actually, what Pollack showed is that the gel becomes negatively charged and it pushes out protons. It pushes protons out into the blood, and it ends up being negatively charged because of that. And it creates a battery, and that battery is a source of energy. So you can think of the gel as being like a battery supporting the entire body. All the gel in the blood is a battery. It's a giant battery. And when you get exposed to sunlight, the gel grows in volume by a lot. And so when the gel gets bigger, it gets to be a bigger battery, and it's capturing the energy in sunlight. It's like a solar panel. Your skin is like a solar panel, capturing the energy in the sunlight and converting it into this energy in that gel that pushes out those protons. And the cool thing is the deuterons tend to stay behind because it's a little bit interesting physics here. When you have a water molecule, could have one deuterium, one hydrogen, and an oxygen. Water is H2O, right? So this would be HDO, one hydrogen, one deuterium, and oxygen, right? HGO. And when you separate that out, usually you separate water out into OH minus and H plus, right? When you pull it apart into ions, OH minus and H plus. Well, what happens here is that the deuterium sticks harder to the oxygen than the hydrogen does. So you get OD minus and H plus more often than OH minus and D plus. So you have a lot fewer D pluses inside that gel, and the H pluses go out into the blood. And the D pluses the Ds are stuck to the oxygen, so they don't go out. So you end up actually, that's a sort of distillation process that pulls healthy protons out of the gel into the blood, and that makes the blood levels of deuterium lower. You see what I'm saying? The deuterium gets trapped in the gel, and the deuterium gets trapped in bone in the same way. In the bone, in the skin. So the body's trying to keep the deuterium out of the cell, and within the cell is trying to keep it out of the mitochondria, and actually out of all the organelles, not just the mitochondria. So there's a whole metabolism cannot be explained without looking at deuterium.
Yeah. So if deuterium is getting trapped in the bone, much like lead does it take up space where we can't have calcium, and then it leads to more osteoporosis as well?
I don't think so. I think deuterium is actually healthy in the bones.
Interesting.
It actually makes the bones stronger. And in fact, there was a really beautiful article on seals. Seals, they do the deep dives. They get into this really high pressure zone in deep water. So they have to be really strong. And the seals actually dope up their bones with twice as much deuterium as what is normal. So they concentrate deuterium. They showed it with the seals. They concentrate deuterium in their bones, and the deuterium makes the bones stronger, so they can sustain the high pressure of the deep dive. Do you hear the thunder? We've got a big thunderstorm here.
So when you're testing for deuterium in saliva, are you testing the excess then? Like what the body doesn't,
well, there's the
waste of
thing.
it?
It's really complicated because I think it's hard to know how to interpret it. It's just like when you test for toxic metals like mercury and lead, like in the hair, you can do a test in the hair. And sometimes you can find someone who actually has a problem with that metal, but the hair doesn't show it because the body doesn't actually excrete it in the hair. So you have to think about, can the body get rid of it that way? And actually in the saliva, I believe the body concentrates deuterium in the saliva because it's trying to get rid of deuterium. So you have the salivary glands, and they can actually preferentially excrete deuterium into the saliva to concentrate it there in order to keep it out of the body. But those enzymes that do that might be compromised, in which case you have less deuterium in your mouth, but that doesn't necessarily mean that's good. You see what I mean? So when you see whatever the level is, it's hard to interpret it, I believe.
Yeah, it's hard to tell what to do with it then.
Yeah, whether it's low because your salivary glands aren't working well, or whether it's low because your whole body's low, and you can't really know which way that goes necessarily. So that makes it hard to interpret, I think.
It sure does. So
but I'm interested, for example, breast milk has low deuterium, saliva has high deuterium, and I haven't been able to find, there's very few measurements, so I'd like to see a lot more measurements on just what's typical, I would expect the urine to have high deuterium, so anything that you're excreting, I would expect it to have high deuterium.
So knowing this information that we have, How does one fix these metabolic issues that we've kind of created in our own environment, for lack of a better term, because of our own misgivings of what we've done in the world? How do we protect our brain and repair that metabolic issue in the mitochondria these days then?
I would say the most essential thing is to eat certified organic food.
Mhm.
Always buy certified organic. It doesn't guarantee that it's free from chemicals, but it's generally better.
Right.
So we've been practicing that ever since 2012 when I figured out that glyphosate is causing a mess. So we went organic, and we've been like that ever since. We did a purge. We threw away everything, even the spices, started over in our kitchen in 2012. And then we've just been consistently buying certified organic ever since then.
It
And
at
I would
least lowers the
encourage.
load, right? I mean,
Yeah,
there
it's
could
a
be
step
some
you can take.
contaminants there, but
It's a lot less generally, but not zero, not necessarily zero, sometimes zero
right,
or
right.
undetectable.
Hmm.
But that's a really important thing. Another thing is to eat, I think eating fiber can help the microbes to produce those low deuterium nutrients. The microbes, we can't digest, our cells don't know what to do with fiber, but the microbes can digest the fiber, turn it into hydrogen gas, turn it back into nutrients like short chain fatty acids, butyrate.
Hmm.
So by eating foods that contain fiber, you're helping the microbes to produce butyrate, and butyrate is really, really important for the health of the colon.
Yeah. And we're talking about eating whole food organic, not organic Doritos and Cheetos and all of
Right,
those kinds of things,
right.
right?
Whole foods is really important. I always say whole foods and organic foods. Those are the two really important things. And then I don't really, there's all these different fad diets with respect to
Yeah.
a loss of fat or no fat and all that kind of thing. I don't
Hmm.
buy into any of those. I think you just want to have a balanced diet. Carbs are okay. Fats are really healthy, and especially animal-based fats are healthy. I don't like a vegan diet because I think animal-based foods provide certain nutrients that are really hard to get otherwise. And like I say, you can't take choline bitartrate to replace the choline that's in the animal-based foods.
Right. Yeah, I've worked a lot and I've never seen a healthy vegan. I mean, we can say we're vegan, but those people are eating a lot of junk food. Typically, they're not true vegans where they're just eating whole food and getting all their nutrients from good quality foods. Most of the people that I've worked with over the years that have been vegan eat a lot of processed foods, a lot of junk
Mm-hmm.
foods. It just doesn't include the animal fats, and then that makes them unhealthy. And we see a lot of nutrient deficiencies and a lot of pain and energy issues. It's very hard to be a healthy vegan, in my opinion, as well.
I agree. I agree.
Yeah.
Yeah.
So I like to ask this question of all of my guests. And if you were designing a public health policy tomorrow, what would your first change be?
To switch the farming system to be small farms that are regenerative, not just organic regenerative small farms
Mhm.
with no use of chemicals, no
That would make a huge
insecticides,
difference.
no fungicides, no herbicides, nothing.
Yeah.
And even natural fertilizer, of course, as well. And of course, right now, the organic farms rely on the chickens to get the
Hmm.
manure,
Yeah.
which has glyphosate in it. So they get their glyphosate from the manure.
Hmm.
So it's
Yeah, because a lot
frustrating.
of that chicken feed has glyphosate in it, and then they're passing that through. And we think that it doesn't pass through, but it does pass through. And yeah, I would agree with you. I think when we went to these big industrial farming practices, we did not do ourselves any favor. And shipping food across the country to be slaughtered only to ship it back here,
It's
it
crazy,
doesn't
isn't
make
it?
any sense. And growing
Yeah.
things in environments where people live that isn't natural to them, that doesn't make sense to me either in a lot of
Yeah.
ways.
Yeah, it's very frustrating because I think it's too bad that we lost all those small family farms because we need them
Yeah.
back. We really need them back. And I think that's really and you want to have a variety of different crops. We have all these massive cornfields. That's just wrong.
Yeah, and they do nothing but corn until your county says you have to do something different now because you've depleted the soil too much, and they don't want to put any soil preservation back in and put any nutrients back in because that's expensive.
Exactly.
And then they'll rotate the crop maybe once a year, and then they're back to growing corn again because that's the largest revenue producer for them at the time. And it really is a challenge for us, really a challenge.
Yeah, it's going to be very difficult to pivot to the kind of agriculture we need. And if we don't do it, we're just going to get sicker and sicker. It's really quite
Hmm.
frightening
Yeah.
how sick we are.
Yeah, and I think people trying to grow their own food, at least some of it, can be really helpful and beneficial too. We need to go back to that
I
practice.
know, yes. Rooftop farms, right? There's like in the
Hmm.
city. That's really quite
Yeah,
cool. I've heard some lectures on that.
yeah. Yeah, even some of the hydroponic growing that you can do in your apartment and get some lettuce and some herbs and things like that. I mean, anything that you can grow yourself, I think is a big benefit. A, you don't
I
have to
think
pay
so
for
too.
it. B, you know how it's been grown. C, it's just healthier for you and it's less that you're going to have to buy that you don't know that what's been grown in it. So it
And
makes a
it's
huge
also kind of
difference.
fun, right? You feel good
Yeah.
that you produce your own food. I think it's really quite neat.
Yeah. And there's something therapeutic about digging in the dirt a little bit and getting your
Yeah,
hands
and it's
dirty and
good to be
connecting with earth.
outdoors. So and
Yeah.
getting exercise. I mean, really, the work that's involved with growing the food is quite healthy work, really.
Yeah, it's a lot of work for sure. That it
Mhm.
is. So, for listeners that might be feeling a little overwhelmed about what we're talking about and thinking about how do I detox or nutrition, where do I get some of this education? What kind of resources would you recommend for them?
It's a tough one. There's not much known about deuterium, so it's really quite
Mm,
difficult to. You can search deuterium, and there are some a couple of good resources which I can't name. I could probably send you a link
okay.
describing deuterium. I know there's a woman who's written some nice material on deuterium just to get a better sense of what it is and why it's a
Yeah.
problem. But there's not much. I mean, we need to have a lot more. I really want to get the research community aware that they need to
Hmm.
be researching deuterium and its role in the body because I think it's absolutely essential. We'll never understand disease if we don't look at deuterium.
Yeah, I think so too. I think that there's a lot of amazing discoveries that are being found that could open the doors and give us answers to reversing a lot of disease. If there was funding behind it, if there were people like you
Right.
that were interested in it to really dig down from a functional medicine standpoint and try to figure it out instead of looking at it from a big pharma aspect where we just
Mm-hmm.
need to find a pill that'll fix it
I
because there
know.
are not pills that are going to fix these kinds of things.
Right. Yes.
Yeah.
Pharma is way off base, I think. They're really going after the completely wrong
Yeah.
approach to health.
I agree. Well, thank you so much for joining to me today. It's been a pleasure. Is there any last words that you want to leave with our listeners?
I don't know. I just, healthy living is basically just eating whole foods, eating organic foods, getting plenty of fiber and fermented foods and healthy fats, sort of, and variety of diet, a really mixed diet, lots of fresh vegetables. I mean, there's all these different great things to eat. Just stay away from the soy protein bars, and the candy
Yeah.
bars and that sort of thing.
Yeah.
And the
Right.
cookies. I mean, just
Hmm.
and then of course getting outside in the sunlight is something I always have to say. I love the sun. I think it's very therapeutic, and we don't get enough sunlight. We're just
We
indoors too
don't.
much.
Mm-mm. And if we do, then we're lathering on all of our sunscreens so that we don't get the sun, and that's creating its own issues, right?
That's right. Mm-hmm.
Yeah. Well, thank you so much for being with me today.
Thank you. My pleasure.
Thank you for joining me today on Let's Talk Wellness Now. If this episode has resonated with you, share it with another woman ready to reclaim their health and their vitality. And remember, wellness isn't just about feeling good, it's about thriving in every area of your life. If you're ready to explore personalized regenerative medicine, please visit serenityhealthcarecenter.com. You can also follow me on social media and join our free program, Seen at Last Community, on Facebook. Until next time, I'm Dr. Deb reminding you to care for your body, mind, and spirit. Be well, and I'll see you on the next episode. Welcome to Let's Talk Wellness Now, where we bring expert insights to you. Please note that the views and information shared by our guests are their own and do not necessarily reflect those of Let's Talk Wellness Now, its management, or our partners. Each affiliate, sponsor, and partner is an independent entity with its own perspectives. Today's content is provided for informational and educational purposes only and should not be considered specific advice, whether financial, medical, or legal. While we strive to present accurate and useful information, we cannot guarantee its completeness or relevance to your unique circumstances. We encourage you to consult a qualified professional to address your individual needs. Your use of information from this broadcast is entirely at your own risk. By continuing to listen, you agree to indemnify and hold Let's Talk Wellness Now and its associates harmless from any claims or damages arising from the use of this content. We may update this disclaimer at any time, and changes will take effect immediately upon posting or broadcast. Thank you for tuning in. We hope you find this episode both insightful and thought-provoking. Listener discretion is advised.